Yes, children. Now in today's class, let us revise about salts. Okay. Now what are the different types of salts? Salts are of three types: acidic salt, basic salt, and neutral salt. Okay. Now, how do you get such neutral, basic, and acidic salt? Let us see. You know very well that a salt is made by neutralization of acid and a base, is it not? HCl plus NaOH will give you NaCl plus water. Now here, both HCl as well as NaOH, they are strong. This is strong acid, this is strong base. So the salt that you derive out of strong acid and strong base is a neutral salt. Okay. Now if the acid is strong but base is weak, then the salt formed is acidic salt, because whichever is strong, that character will come in the salt. Okay. So if acid is strong, then the salt will be acidic salt. Whereas if the base is strong, then if the base is strong and acid is weak, then the salt formed is a basic salt. Okay. Now look at the example here. HCl plus NH4OH. NH4OH is a weak base. I have already told you about weak bases and strong bases. And this is a strong acid, so the salt is acidic. You get ammonium chloride. If the base is strong and the acid is weak, say carbonic acid, H2CO3 is carbonic acid, which is a weak acid, and sodium hydroxide is a strong base. So what you get out of it is sodium carbonate, which is a basic salt. Okay. There are questions in the board. An aqueous solution of sodium carbonate is alkaline. Why? The question is, an aqueous solution of sodium carbonate is alkaline. Why? This is a board question. Okay. Now what are you supposed to write? The sodium carbonate is formed from NaOH and carbonic acid. NaOH is a strong base and carbonic acid is a weak acid. That is why the salt that is formed is alkaline, that is basic. Alkaline means basic in nature. Okay. Okay. Now let us see a few more examples based on this. Remember, strong acids are HCl, H2SO4, HNO3. Weak acids are carbonic acid, phosphoric acid, acetic acid, formic acid. They are all weak acids. Okay. Now these two are organic acids. Wherever you are having COOH group, COOH, they are all called as organic acids. These two are called organic acids. I have already given you these notes. It's all there with you. Just check with it. Okay. Now apart from organic acid, even citric acid is a weak acid and it is also an organic acid. Okay. Now strong bases, sodium hydroxide, potassium hydroxide, they are strong bases. Weak bases you have ammonium hydroxide, magnesium hydroxide, and calcium hydroxide. These are weak bases. Now look at the kind of salt that we are getting. HCl plus NaOH gives NaCl plus water. So what kind of a salt it is? Neutral, because both are strong. HNO3 and NaOH. Again, this is a strong acid, this is a strong base, so you get a neutral salt. Now this is a strong acid, this is a weak base, and the salt is acidic salt. Okay. This is a strong acid, this is a strong base, so you get a neutral salt. H3PO4 is a weak acid, KOH is a strong base, so you get a basic salt. Whichever is strong, that character will come in the salt. Okay. Whichever is strong, that character will come in the salt. So I have given you some more examples like this. Right. It is all there in your notebook. You must be able to see it. Okay. See, I have given you the same question. Why is an aqueous solution of sodium carbonate alkaline? Na2CO3 is an alkaline salt because it is made up of a strong alkali and weak acid. So it is basic in nature. So it is alkaline in nature. Then I gave you one exercise also. Right? You may do this again. Now if I give you the name of the salt, you have to say which acid and which base will give you this salt. Like potassium nitrate is formed from nitric acid and potassium hydroxide. And what is the nature of salt? The nature of salt is neutral. Same way sodium acetate. Okay, what is the formula of sodium acetate? From which acid you get, from which base you get, and what is the nature of salt. Okay, so this exercise I'll give you and you have to write and show me. Now let us come to the actual salts. Now before coming to salt, let me also tell you about what do you mean by family of salts. Now look, family of salts. Now all these are sodium salts, sodium chloride, sodium sulfate, sodium nitrate, sodium carbonate, sodium phosphate. They are all sodium salts. So you can call it as sodium family. Same way, this can be called as potassium family. This can be called as magnesium family, right? Same way. See here what is common? Your metal part is common, is it not? The cationic part is common. The positive charge part is common. But you can say the other way also, where now see, this part is different, but this is same. All are chlorides, right? So you say this is belonging to chloride family. Sodium chloride, potassium chloride, magnesium chloride. Now all of them are chlorides. Same way all are sulfates. All are nitrates. Okay, so you call them as nitrate family, sulfate family, chloride family, like that you will call it. Okay, now let us see about common salt, that is sodium chloride. Now the most important thing that you see about this is Chlor-alkali process. Now salt is obtained by the evaporation of seawater in certain shallow pits called lagoons. Okay, so that is in general. Now what happens when an aqueous solution of sodium chloride is electrolyzed? If you pass electric current through an aqueous solution of sodium chloride, what will happen? That is what we are going to see. Now when electricity is passed through an aqueous solution of sodium chloride, chlorine gas is produced at the anode and hydrogen gas is produced at the cathode. Now along with this, sodium hydroxide is also produced as a byproduct. Where is it produced? It is produced near the cathode. Now look here, look at the equation. NaCl plus water, when you pass electricity, you will get NaOH plus H2 plus Cl2. Now this question is very, very, very important. They can ask you, why is it called Chlor-alkali process? It is because chlorine and alkali are formed in the process. That is why it is called as Chlor-alkali process. Okay. Now, how will you remember that hydrogen is produced at the cathode and chlorine is produced at the anode? Okay. So now to understand that, I am giving you a simple logic. This NaCl plus water you are adding, is it not? Now NaCl will split in the form of Na plus and Cl minus, and water you can expect it to split in the form of H plus and OH minus, right? Now you know very well that anode is positive and cathode is negative. Okay. Now when the solution is electrolyzed, this solution is electrolyzed. Okay. So the positive part will go towards the cathode and negative part will go towards the anode. Is it not? Positive towards the opposite charge, that is negative, and negative towards positive. Okay. So Na plus and H plus will move towards cathode and Cl minus and OH minus will move towards anode. Okay. That is what I have given. Now out of Na plus and H plus, which will reach the cathode first? It is H plus which will reach the cathode first. So cathode में जा करके ये H plus क्या बनेगा? H2 बन जाएगा. It will become molecular hydrogen. Okay. Now out of Cl minus and OH minus, out of these two, which will reach the anode first? Cl minus will reach the anode first and it will get oxidized to form Cl2. Okay. At the anode, it is oxidation. At the cathode, it is reduction. Always remember. Okay. Even in higher classes also, this concept will not change. At the anode, what happens? Oxidation. At the cathode, what happens? Reduction. AOCR. Okay, AOCR at the anode oxidation, at the cathode reduction. हमेशा याद रखना इस चीज को, ठीक है? Okay. So Cl minus will get oxidized to form Cl2. Okay, that's how you have to remember, right? So this equation is extremely important. Now let us see what are the uses of the products obtained in this chlor-alkali process: NaOH, chlorine and hydrogen. NaOH is used for degreasing metals. Then it is used in the manufacture of soaps, detergents, paper, artificial fibers. Everywhere it is used. Then chlorine is used in the production of bleaching powder. It is also used in the production of HCl. Then PVC, plastic. PVC is polyvinyl chloride. And then various pesticides, chloroform, सब बनाने के लिए chlorine काम आता है. Then how do you use hydrogen? Hydrogen is a rocket fuel and it is used to make ammonia for fertilizers. What is ammonia? Ammonia is NH3. How is this ammonia made? Nitrogen plus 3 hydrogen together will give you ammonia. So hydrogen is used for the manufacture of ammonia. This ammonia will further be used in the preparation of fertilizers. Okay, like this ammonia, if it is treated with sulfuric acid, you will get ammonium sulfate. Now ammonium sulfate is a fertilizer. And also it is used in the hydrogenation of oils to produce vegetable ghee. That is, you have oil, it is converted into ghee. Okay, vegetable oil is converted into vanaspati ghee. Vanaspati सुना होगा आपने? It is not cow ghee. It is not cow ghee. It is artificially prepared ghee. Vegetable oil is converted into vanaspati ghee by treatment with hydrogen in the presence of nickel or platinum as catalyst. Okay, so addition of hydrogen is called hydrogenation. Hydrogenation is also called as reduction. Okay, vegetable oil is reduced to give vanaspati ghee. Okay, cheap hai. Cow ghee is very expensive, whereas this vanaspati ghee is less expensive. It is not that costly. Okay, so this is about chlor-alkali process. Now we'll have to go to bleaching powder. The next salt is bleaching powder. How do you prepare bleaching powder? Bleaching powder is CaOCl2, calcium oxychloride. Calcium oxychloride. Okay. How it is prepared? It is passed by passing chlorine through dry slaked lime. CaOH type is also called as slaked lime. It is also called as slaked lime. Now, in the dry state, chlorine gas is passed through it and you get bleaching powder. Okay. And where and all bleaching powder is used? It is used to bleach cotton, then in textile industry, then wood pulp that is used in paper industry. It is also used to sterilize drinking water, and it is also used in the preparation of chloroform. Chloroform is CHCl3. This is called chloroform. So chlorine is used, isn't it? So chlorine का source की तरह ये bleaching powder काम आता है. Then as an oxidizing agent in chemical industries. Okay.